Alright, so the vertices from our last example, we had 0, 0, we had 0, 300, we had 400, 0, and the last vertex that we needed to use elimination to solve for was 250, 150. So our goal in this one is to maximize this objective function for these constraints. We just grabbed the feasible region for these same constraints on example 1. And using that last vocab term again, the max or min will only occur at one of the vertices. So these are the only 4 ordered pairs that we need to check. And I'm actually not even going to check 0, 0, because I can tell you right now, 0 plus 0 is not going to maximize this function. So we're down to 3 vertices. So we can set up a little chart. And I'm going to put the objective function in the middle. And then this will be our answer, our max or min. In this case, max. So we're going to start with 0, 300. Substituting that into our function, 10 times 0 obviously is 0, so we'll do 16 times 300, which is 4,800. And then we've got our second ordered pair, 400, 0. Similar, we really just got 10 times 400, which gives us 4,000. And then our last one, 250, 150. So we have 10 times 250 plus 16 times 150 gives us a value of 4,900. So by a small margin, that last vertex did give us our maximum value. So we would somehow make a note that we know which vertex maximizes the function. Next example, we're going to take a look at writing inequalities. I think we did this in chapter 2, so now we need to write a system. We're going to be writing 3 inequalities for our feasible region. We're just going to use a different term for it. So I'm going to start with my red inequality, and what's nice is all of these are solid lines, so they will all be or equal to's. What I'm noticing, and again, I'm given the ordered pairs where they meet. The lines may not be graphed perfectly, but these ordered pairs here are where they meet. So my red line goes through 0, 0. So my y-intercept is 0. I need to find my slope. Goes through negative 1, 1. So the slope would be negative 1. So y equals negative x. Sorry, and I already forgot these were inequalities. So we've got some sort of or equal to since it's a solid line. And I can't use 0, 0 since my line goes through 0, 0. So I'm going to use the ordered pair 0, 1 instead, and it needs to be true. So when I substitute 0 for x and 1 for y, 1 is greater than or equal to 0. Looking at my green inequality, this one has an intercept of 2 and a slope. It goes through 2, 4, so slope of 2 over 2 or 1. And again, I'm going to use that ordered pair 0, 1. If I substitute 0 for x and 1 for y, it needs to be true. So in this case, it is 0 plus 2 is greater than or equal to 1. And finally, my blue line, which also goes through 0, 0 and 2, 4. So this one has a slope of 2 and a y-intercept of 0. Again, using that same ordered pair, we need 0, 1 to make it true. So in this case, again, it'll be greater than or equal to. So this is our system of inequalities for the feasible region that was graphed for us. And you try.